There is no doubt that the IoT is network-oriented. Even the name IoT naturally relates to the Internet network. Communication is an essential part of IoT ideas. Every IoT device, even the simplest passive RFID tag, must somehow communicate. Communication is always performed according to rules known to both parties. People use different languages, and devices have protocols. The communication protocol describes how to address the information to the remote device, encode the data, and check the incoming message's correctness. Communication in IoT devices can be wired or wireless. And note, Edge-class devices mainly use wireless transmission. Fog-class devices use both, particularly as gateways or routers. The cloud segment of the IoT ecosystem extensively uses wired Cooper and optical. IoT networking differs significantly from typical multi-layered, stack-oriented TCP/IP or similar communication models we know while using our PCs, Macs, servers, or smartphones. Indeed, constrained IoT devices can usually not operate regularly full-time on an ISO-OC layered stack because of constrained resources. IoT devices are expected to be energy efficient and thus low-powered, usually excluding typical wireless communication standards like, for example, Wi-Fi. Also, the daily life cycle of IoT device is much different from that of PC life cycles. IoT devices are expected to be sleeping, providing low power mode whenever possible, and on the other hand, they are supposed to be fully operable when only needed. Most performant IoT tasks related to sensing have a cyclical nature, example, measuring gases in a sensor network node. In contrast, the period can be between seconds and months or even longer. They are usually expected to be triggered themselves to be awake from sleep, perform some operation, and connect to the network. Meanwhile, the network grid needs to be aware that those devices are still in the place, in good condition, and can awake, example, the battery is not being drained. Because of the existence of different IoT devices, including those very constrained from 8-bit processors with some kilobyte of the RAM to 32-bit multi-core machines well replacing PCs, IoT networking is very competitive on protocols, approaches, and solutions. Standardization organizations like III indeed introduce some networking standards, yet they are competed by large manufacturers, forcing their complex solutions, including dedicated hardware, software, and protocols. The third force driving this market is open solutions and enthusiasts, usually working with cheap equipment, providing de facto standards for many hobbyists and industries.